do that, I would just like to bring some things to mind. So for the most part, people are getting the whole calculation of oxidation reduction numbers, but there are just a couple of occasions. So when we have a compound, complex ion, something like, we'll go with, I don't know why this changed color. If we have something like Na2CO3, what some people are doing is they are saying this is -2, this whole thing, which is correct, and they may say this side is +2. That is correct, but when we're calculating our oxidation states, we're doing it for one element in there. So while this half is -2 on the right and this side on the left is +2, the -2 refers to the whole complex ion, and you have to break down what everything individually is. So you can use the -2 absolutely to work out what these things are. So if oxygen is -2, there are 3 of them, -6, and you need to have -2 left over, then that must mean carbon in this instance is +4. You can absolutely use that way to do it, but you can also do it from this old school, going oxygen is -2, you have 3 of them, is -6, everything over to this side must be +6. By the group 1 rule, sodium has to be +1, you have 2 of them, it must mean carbon has to be +4. So we are now going to start balancing chemical equations, and when we do that, we are looking to find the oxidation state for one of each element in our formula or in our equation. So you need to break it down into these versions here, because that's the only way you're going to be able to tell is it going to be oxidized or reduced. So I'm going to use a Word document this morning. It's going to kind of pretty much match your book. It's page 1112 on my version. It just says in the top, putting it all together, balancing half equations. Now we're going to do a little bit of what you have been doing. So this is at the bottom of the page and I've just brought it up to the top. So I'm going to ask you to just do these ones. All we're doing is figuring out what is oxidized and what is reduced. And what I would like for you to do, please, once you've figured out what is oxidized, and I'm not saying this is in any way correct, I'm just putting it in, I want you to put the square brackets. I want you to make sure that the beginning of the square bracket is on the element that is the thing being oxidized and it ends on the element that is being reduced. I want you to just put ox above one and red above the other, and as I say, I haven't looked at these, so I could be doing it completely wrong, but it's really, really important, especially in, say, a compound like this, that if the link, I want you to make the link from here to here if these are the elements that we're involved in. So off you go, and I'm going to fix this one at the end. You don't have it, but I just want to have a quick chat about it. So I'm going to leave you do these. I'm just going to fix this one at the end. So I'm going to pause my share and you're going to start these. I'm just going to see where Charlie is. Okay, so up here, when you're writing these now, you're just, so chlorine is element or 0, bromine is the simple ion rule, so -1, chlorine over here, simple ion rule, -1, and bromine here is an element, so 0. When we do these, you will be getting them unbalanced from the SEC, so the 2's in front of the bromide and the chloride don't matter. And then you're using the OIR and the RDL. So oxidation is an increase in oxidation number, so that's the -1 to 0, so that gets the ox. And reduction is a decrease in oxidation number, so this is the red in this instance. Down here for the second one, the bromine here is a 0. It is a -2 for the oxygen, makes the sulfur here a +4. This is always -2 and a +1 in water. Usually nothing happens to them unless you have elemental oxygen somewhere in your equation. Here, bromine is -1, hydrogen +1. Here for your sulfate, -2, hydrogen +1, and your sulfur in here +6. So then when you look at it, it is going from +4 to +6 for your sulfur. So that is your oxidation, and your reduction is going from 0 to -1 for your bromine. Okay, you shout now if you have questions or issues. So down here, -1, +1, chlorine is an element, -1, +1, bromine is an element. So I am going from -1 to 0 is my ox, and I am going from 0 to -1 is my reduction. So just put this one in at the end. So chlorine is 0 because it's an element, -2, +1, -1, +1, -2, +1 means my chlorine here is +1. So I'm now going from 0 to +1 for my chlorine here. This is oxidation. I'm also going from 0 to -1 here. This is reduction. So we have this chlorine is both oxidized and reduced. And you can see this written sometimes in a question. It's called a disproportionation reaction when something is both oxidized and reduced. Now, my husband and I were talking about these last night because there's one of them in Chemistry Live, and I don't remember it ever coming up. He thinks there is one there, so I'll have a rummage and see can I find, because for the next thing that we're going to do for actually balancing a chemical equation, disproportionation is tough. But what we kind of figured out was that if she was to give it, you could probably do it just by balancing the elements rather than oxidation states. She could not be that mean to individuals. Okay, so are we all getting those numbers? Okay, because we really need to be getting them for these. So for the first bit of this, I am going to do it as examples for you. These ones here, you can probably do them without having to go into oxidation states. But again, my husband and I were talking about it last night. There are ones that aren't going to be obvious that you are going to need oxidation numbers. So if you can get happy in an oxidation redox question using this method, then that's going to help you. So if you look to the top of the next page, there is here these are rules for balancing equations that are not ionic. So we would ignore this part here for now, but we will determine our oxidation number for all species. So you've been doing that already. We would look at what is oxidized and what is reduced. You've been looking at that. We now have to write our half equations. So we're ignoring this NB part because it's not relevant for our beginning. Okay, but we are going to be multiplying then our half equations so that we have the same number of electrons on both sides, and then we're going to rewrite. Now for the two that are on the bottom of page 112, you are going to be able to probably do it without going through using oxidation numbers, but I would really like for you to get into that method. So we look up here and we just do it with oxidation numbers. So our chlorine is 0, our bromine is a -1, our bromide, apologies, our bromine here is a 0, and our chloride is a -1. So when I write these out, I will, once I figured out what is oxidized and what is reduced, I write this down here as opposed to these, even to this day, to just keep reminding myself what it is I need to do. So here our bromide is going to, our bromide is going to bromine, so this is our oxidation, and our chlorine is going to chloride, this is reduction. And if they ask you to write in what's the oxidizing agent or the reducing agent, I personally would just circle it and label it properly, full words. So the rule is, for our oxidation, we're looking for the increase in oxidation number, but when we write what's called a half equation, our electrons go on the right hand side. So Br minus goes to Br2, and my electrons are going to go on the right hand side, and here I have going from -1 to 0, that is worth 1 electron. Now there is a caveat when you deal with the halogens. It's mostly the halogens, but it can happen with other things. And here I have 2 bromines, but I only have 1 on the left hand side. So before I even look at internal balancing or all of the little bits, I need to put in a 2 here, and I need to change this to 2 electrons. And the reason I do that is because when we write our numbers up here, we are writing for 1 element, and I happen to have 2 elements here. So I have to take that into consideration. So then I go for my chlorine, and it is the reduction, and my electrons have to go now on the left hand side. So I write Cl2, and when I look at my line, it's going from 0 to -1. That is only 1 electron, and it's making me Cl minus chloride. And again, I have the exact same thing with the halogens. I have 2 chlorines on this side, I need to put 2 on the right, and if I do that, I have to change my oxidation number to here. Okay, so I'm getting the number of electrons from the difference of the elements in my square brackets. I'm just going to shove this down ever so slightly. So if my electrons are the same on both sides of my arrow, so I have 2 here and I have 2 here, then I don't need to do anything else. So I can cross these out and I rewrite everything as it stands. So when I rewrite, it'll be Cl2 plus 2 Br minus goes to Br2 plus 2Cl. Now I know we can absolutely positively have done that without getting into oxidation states and half equations, but it's okay, so it just says down here, a change of 1 oxidation number is a change of only 1 electron. So you're getting the number of electrons from the links in your square brackets. So then just down here for our magnesium, so that's going to be 0. This is going to be -2 for oxygen here, +2 for copper here, -2 for oxygen here, +2 for magnesium here, and 0 for copper here because they're elements. So then I am going from 0 to +2. This is my oxidation. I am going from +2 to 0 here. This is my reduction. So I go OIR, I go ORDL, magnesium goes to magnesium oxide plus, in this instance, 2 electrons. My copper oxide plus 2 electrons is going to Cu. My electrons match. I don't need to do anything else. And I just rewrite final. So cross out, Mg plus CuO becomes MgO plus Cu. Okay, we as content as we can be. Alrighty, so let's get to the good stuff. So now is where we're going to all put it all together now. So we will have a mix of ionic. The first equation here is ionic. The second one is a mixture of ionic and covalent compounds. So essentially, you can ignore OH, H plus and H2O. I would still find their oxidation states, or at least write them underneath them. But in terms of trying to balance them, we're ignoring them for now. So we're doing our steps. We're determining our oxidation number. We're figuring out what is oxidized and what is reduced. We are writing half equations, and we have to bear in mind something that looks like this. We have to balance it before we do our final balancing. We haven't really done this line yet. Multiply each equation so that both equations have the same number of electrons. Once we've done that, we're rewriting our equation, the full equation. So the thing, if it has an OH minus and a H2O, or if it has a H plus and a H2O, we put them in. And we always balance our oxygen first, and we always balance our protons last, because it goes back to when we were doing our balancing of equations. It's easier to add single elements in at the end as opposed to compounds, because that just screws it all up. So I'm going to do these two with you, and then I'm going to leave you off. So our chlorine is -1. There's 2 of them. It must make copper here +2. My aluminium is an element, 0. My copper here is an element, 0. My chlorine here is a -1. I have 3 of them. It makes aluminium +3. So I am going from 0 to +3. This is my oxidation, and I am going from chloride. Right, no, I'm going from copper 2 to copper 0. So this is my reduction. So I go OIR. I am going aluminium goes to aluminium chloride, and there are 3 electrons involved. I do my RDL. I am going from copper to chloride plus 2 electrons going to Cu. So this is, we don't have the same number of electrons on both sides here. So I now have to figure out essentially what multiple I can put in so that they will have the same number. So if I multiply my top line by 2 and my bottom line by 3, I will turn my electrons into 6 electrons. So now I have 2Al, 2AlCl3. This turns into 6 electrons. Down here I have 3 copper chlorides plus 6 electrons plus 3 coppers. So because my electrons cancel out, I am now good to rewrite. So it will be 3CuCl2 plus 2Al becomes 3Cu plus 2AlCl3. I don't have any H pluses or OH minuses or H2Os to get involved in. Okay. So we have a look at this one. So this is more like what you would get. So zinc is 0 because it's an element. This is a complex ion, so I have to have the -1 left over. So my oxygen is -2. There's 3 of them, -6. 1 left over, -5. It makes my nitrogen +5. Proton +1. Zinc is 2 plus charge because it's a simple ion. Here, this is going to be +1. There are 4 of them. It means here each nitrogen, must be worth -2. And over here for water, it's always -2, +1. So now I look across my line. Z to Zn is an oxidation. +5 to -2 is a reduction. So I write my half equations. So I am going for Z to Zn 2 plus 2e minus. I've got the same number of zincs on both sides, so I don't have to do anything to them. Here for the RDL, it is going NO3 minus plus 5, 6, 7 electrons is going to N2H4. So I'm only interested in my ends. I have 2 ends here, so I now need to change this so that it's going to match. So it's going to change the color of my pen so you can see it. So I'm going to put 2 here, and I have to turn this into 14 electrons. So now I have, for 2 nitrogens being reduced, it's going to gain 14 electrons. Nope, here's where I want to be. So to get my electrons the same, I need to multiply this line by 7. So 7 zincs, 14 electrons. So my 14 electrons are now the exact same, so I can cross these out and I can rewrite the whole equation that is up here at number 2. So it is 7Zn plus 2NO3 minus plus H plus becomes 7Zn2 plus N2H4 plus H2O. And according to my rules above, it says I balance my oxygen first. So on this left side...
Miss, why did you put 2 before the NO3?
Because when you do up here, when you did this part, Miles... No, I'll get there. When you did this part here, +5 to -2, that changes for 1 nitrogen. But you have 2 nitrogens down here on the N2H4. So you have to do you have double the electrons or double the nitrogen, so you have to double your electrons. So you have to do a kind of internal balancing of your ends. You need to make sure, you need to make sure that you have the same number of ends on both sides. And if you had to add in a second nitrogen, you have to add in the equivalent number of electrons, which is why we increased it to 14.
Miss, why is it 7 electrons? Would not be like 3, because it's like plus and the minus.
No, because you're thinking it like a number line now. It's not a subtraction. It's like a number line. You're at +5 and you're going all the way down to -2. And to get there, that is 7 jumps.
Alright, okay.
Okay. Good questions. Is there any other ones? Okay, so our last bit, it says we balance our O's. So the side that usually has the water probably doesn't have any other oxygens, but you still have to look at both sides. So over here I have 2 by 3 oxygens, so that is 6 oxygen over here, and over here I only have 1 oxygen. So to get the same number of oxygens on both sides, I have to put the number 6 here. Are you happy with that? So now I have the same number of oxygens on both sides, and now I look at my elements. So I'm looking at hydrogen. I've got to balance my hydrogen last. So over here I have 6 by 2. I'm going to change the color of my highlighter. So for hydrogens here I have 6 by 2 is 12, and I have 4. So I have on this side 12 plus 4 hydrogens, which makes 20 hydrogens, and over on this left hand side I only have 1 hydrogen, so I put 20 in front of this, and now this is balanced. So you have to follow the process. You've got to follow the rules. There is...
Yes.
Yeah.
Where did you get the 20 from? Sorry.
Okay, am I not doing my maths right? Thank you, Jim. I'm not doing my maths right. I'm glad somebody is awake. Keep going backwards. 12 plus 4 is 16. Thank you. I am sometimes not good at maths. Okay. So you can see now you may have been able to balance ends without going into oxidation numbers, but it wouldn't have given you the 7 in front of the zincs. There's no way you would have put them there. So that's why you have to do the oxidation states, because you can't predict. So on the top of page 114, there are 1, 2, 3, 4, 5, 6, 7 equations for you to do. I will put up the numbers for them so you can see what they are. And I'm going to stop recording this portion now, so my screen will disappear and I will just see your lovely faces. I am going to stop my share for now. I'm going to record this.